Hello everyone, Mr. Schultz here. Welcome to Integrated 2, Chapter 1, Section 2, Angle Bisectors. So make sure you write your information in the left and right hand corners, and make sure you write the title, Angle Bisectors. So remembering previously, the perpendicular bisector split a line segment in half. Split the line in half. So complete the sentence. An angle bisector splits what? An angle bisector splits an angle in half. All right, so let's continue this. So if a point is on the bisector of an angle, then it is equidistant from the sides of the angle. So what does that mean? So this F right here, it's on the angle bisector. That means BDF is the same measurement, like 30 degrees, as EBF. That would be 30 degrees, hypothetically. Since this is the angle bisector, it bisects this angle, then F is equidistance from the sides of the angle. It's equidistance from, this leg and this leg. DF is equal to DE. Let's go on. Before we continue, when I make these little hash marks, that means that, this is equal in value as the other one. Now, we can do 2 to designate, this one is equal to this one. So if we're going to have multiple of these, and we're going to say, this is equal to that, then we're going to put these hash marks. One hash mark to one hash mark, 2 hash marks to 2 hash marks, 3 to 3, and so on, depending on how many we are comparing. Let's go on. So the converse of that, if a point in the interior of an angle is equidistance from the sides of an angle, then it is on the angle bisector, or the bisector of an angle. So the example of this, they're saying, look, if this DF and FE are equidistant, then they're saying, then this BF, this line BF, is going to be the angle bisector. That means BDF is equal to FBE. Let's continue. All right, so now it says, use the perpendicular bisector theorem. All right, so we know that, QRT it shows it right here. That's what it shows right here. It says QRT is equal to TRS. So the first thing we know is, RT is the angle bisector of QRS. We understand that QT, because of that, QT, we could state that QT is equal to TS because of the angle bisector theorem. All right, next up. Since we know that they're equal, we can take the values for each one and substitute them in. What did we just do? Substitute them in. So QT is 4x plus 8, and TS is 9x plus 7. Now we can solve, and this is more algebraic, but it would be minusing 4x on both sides using the subtraction property of equality, and then we would plus 7 on both sides using the addition property of equality. After that, we get 15 is equal to 5x. Now we can use the division property of equality to determine that, 3 is equal to x. But the problem is we're not looking for what is x. We're looking, what's EF equal to? So taking this, I can continue this up here. Or if I had my own paper, I'd be writing it down right now. I'm looking for EF. Wait a second here. technically I'm not looking for EF. I'm looking for QT. Sorry, guys. So I'm looking for QT. Well, QT is equal to, so QT is equal to 4x plus 8. That's given. Well, okay, well, if that's equal to that, I can substitute this in. And if I substitute it in, eventually I get QT is equal to 20. Now, so the problem with this is we're not really giving two-column proofs we're not really doing proofs right now. We're doing an informal proof. We're just solving it and we're showing work. So when we start doing proofs, we're going to get a little more tighten up what we're supposed to be, like how we're proving this, okay? Let's go on. All right, so the converse of the angle bisector theorem. So we're figuring out, hey, what is the measurement of ZYW? Okay, big ol' hint. We already know it's going to be the same. It's going to be 38 degrees, but the point is not to be like, hey, this is 38 degrees. Why? I don't know. It's 38. The point is to use our logic to figure it out. So let's set up our proof. All right, so let me type it up first. All right, so they're saying, hey, WX right here is perpendicular to YX right here. And saying WZ is perpendicular to YZ. And WX is equal to WZ. W is equidistance or equal in distance from the sides of angle XYZ. Because of this, by the converse of the angle bisector theorem, we know that YW, and this is going to be the ray YW, that means, it has one point and goes forever off in one direction, bisects angle XYZ. Once again, we're not solving XYZ, we're solving for ZYW. What is ZYW? Well, then, we understand the definition of the angle bisector. We understand that, well, let's type it out. All right, here we go. The definition of the angle bisector would say, hey, look, this angle ZYW is going to be congruent, not equal, but congruent, meaning it's not equal, meaning it's not the same. It's congruent, has the same measurement to the angle of XYW. That means they have the same value. And so the measure of angle ZYW, because they are congruent, is going to equal the measure of angle XYW. This is the definition of congruent angles. Well, if that's the case, we understand that the measure of angle ZYW is equal to 38 degrees. So when we jump back into two-column proofs, it's going to be a really interesting time to take all of this and firm it up. All right, let's go on. All right, so now we're going to deal with the in-center. So that means the inside circle. So P, if the angle bisectors of a triangle intersect at a point called that is equidistant from the sides of the triangle. So that was like the construction quiz. Bisect the angles and they meet at a point. At that point, you can draw a circle in the center, and that would be touching each of the sides. This is what would be called the in-center. So if P is the in-center of triangle ABC, then PD equals PE is equal to PF. Basically, we could draw a circle in here. Now, I'd rather draw a better circle, but like this is the circle we had to draw, and some of yours look a whole lot better than that. we should use our tools on that. But for right now, we're fine. All right, let's go on. So use the in-center theorem. So now that we've created those, now we can use the in-center theorem. All right, so let's see if we can get this. So we know that P is the in-center. So P, the given information, P is the in-center of triangle XYZ. All right, so if we know that, we understand that XP bisects angle LXK. Give you a second. All right, so that's saying, hey, look, this guy right here is going to bisect it. So we know, hey, look, these are going to be congruent. Their measurements are going to be the same, equal. Furthermore, we know that, hey, look, with this YP is going to bisect, the YP is going to bisect JYK. So YP bisects angle JYK. And furthermore, so we know that's this one right here. Furthermore, we know ZP, so ZP bisects angle LZJ. All right, cool. So we want to find LZP. Right now, LZP. What is this? Angle LZP. So we want to know what is this. So what we're going to do is we're going to say, okay, if we know, let's find out. So we know that the measure, so then, because of this, we know that the measure of angle LXK will equal 2 times the measurement of angle PXK. So if that's the case, we can do a substitution, and we have 24.6 times 2 will equal the measurement of angle LXK. All right, well then the measurement of angle LXK is going to be 49.2. And we can do the same thing for this one right here. We know that JYP, well actually JYK, let's say the measure of JYK is equal to 2 times the measurement of JYP. Now at this point you might be thinking, what's he doing? Well, let's hold up for a second. So this would be 2 times 25.1. So the measure of JYK is equal to 50.2. Oh, there's my remaining dog right there. All right, give me a second. All right, so basically what we're doing is we're figuring out the measure of this guy. Let's call it measure 1. Then we have the angle 2 right here. We're going to figure out angle 3 right here and then divide it by 2. That's pretty much what we're going to do. Because we know that the, triangle angle sum theorem, we know that, hey, look, this is 49.2. So this one was 49.2 plus 50.2 plus whatever LZJ is, the measure of angle LZJ will equal 180. If we subtract this out, we get the measure of LZJ, the measure of angle LZJ will equal 80.6. Well, then all we have to do is we need to divide it by 2. When we divide it by 2, we get 40.3. There we go. Where is it going? All right, looking at this, it says to use the angle bisectors in design. A new art sculpture will be placed in the courtyard of a high school. The entrances to the courtyard are located at points A, B, and C. Find the location of the center of the sculpture so that it is equidistant from the sides of the courtyard. From the sides, not from the vertices. So how can we solve this? Well, basically, if we were given this on a test, we would see these and we'd have to bisect them. And then when we bisected them, remember that from that quiz that we had, the angle bisectors, we'd find out the one location to draw the circle and figure out, hey, it should be right here. Except we don't have to draw the circle. The point would be our in center right there. All right, so looking at this, I see that's going to be like, looks like 8.2. Let's say that's like 8.2. It'd probably be like 8.2, comma, and going up would be 4.5. No, 4.4. I'd say 4.4. Now they did all our work for you. We didn't need to, find the angle bisectors. But that's what we would put on a quiz. So, for example, a construction quiz that we had. All right, guys. Thank you for watching this, and I'll see you in class.